All the problems in this video have made their appearance on India's JEE main test, and that test is a precursor to the admissions exam into IIT. For this exam, students are given 1.5 minutes per problem. So the first problem is to calculate this bounded integral. We also have the second problem to calculate this bounded integral, and finally we are going to calculate this third integral. As you can see, IIT is not a joke. Even the Wall Street Journal has covered them in one of their stories, and they wrote, "The IITs become islands of excellence," and so on. Candidates are accepted only if they pass a grueling entrance exam. Let's now talk about the technique which is going to help us in solving all of these problems very fast. We are going to use a formula that integral from a to b of f of x divided by f of a plus b minus x plus f of x differential of x is equal to b minus a over 2. First, I want to show you the proof of this formula. Let's name the integral which we are working with integral from a to b f of x divided by f of a plus b minus x plus f of x differential of x as I. Now we are going to introduce the substitution that u is equal to a plus b minus x, and that is going to give us that the differential of u is equal to negative differential of x. The integral I is then transformed into an integral from b to a f of a plus b minus u divided by f of u plus f of a plus b minus u multiplied by the negative differential of u. As you can see here, the limits of integration have flipped. We have integral from b to a. We can use the negative sign here to flip these borders of integration again. So we get this to be an integral from a to b f of a plus b minus u divided by f of u plus f of a plus b minus u differential of u. If you look carefully, you will notice that this integral, which depends on the variable u, has what we call a dummy variable. We can write x for this u and not change a thing. So let's do that. We have an integral I to be integral from a to b f of a plus b minus x. Instead of u we are writing x, and we have f of x plus f of a plus b minus x dx. The integral which we had started from is an integral from a to b f of x divided by f of a plus b minus x plus f of x dx. Let's add these two integrals together, and then we get that 2I is equal to an integral from a to b. The denominator of both of these fractions is the same, so we get f of x plus f of a plus b minus x, and in the numerator we have f of a plus b minus x from the first integral and plus f of x from the second integral, and we are going to keep the differential respectful of x. If you look closely at this fraction here, it is equal to 1, and then we get an integral from a to b differential of x, and that is x from a to b, and that is b minus a. From there we get that I is equal to 1/2 of b minus a, and finally we get that integral from a to b f of x divided by f of a plus b minus x plus f of x dx is equal to b minus a over 2, thus proving the formula. Let's use this formula to solve the first integral on our list. We are going to take that f of x is equal to the square root of x the part of the square root of 6 minus x we can write as a square root from 2 plus 4 minus x, as 2 plus 4 is equal to 6. And if you look closely, this is f of 2 plus 4 minus x. So the integral which we are working with becomes an integral from 2 to 4, f of x divided by f of 2 plus 4 minus x plus f of x dx. As you can see, this integral corresponds perfectly with the formula, so we can apply it and get this integral evaluated. So we get that this is equal to 4 minus 2 divided by 2, which is equal to 2 over 2, and that is 1. As you can see, this integral was easily solved by applying the formula. Let's now solve the next integral on our list. This integral also corresponds with the given formula. Remember, the formula is an integral from a to b f of x divided by f of a plus b minus x plus f of x differential of x equal to b minus a over 2. The only challenging part is to see how. Let's take that f of x is a square root of sine x. The question is, what are we going to do with a cosine of x under the square root? The cosine function is a sine function moved by p half, if you recall from trigonometry. So you can write cosine of x as sine of p half minus x. This is then equal to f of p half minus x. We can apply the formula now and write our integral as an integral from 0 to p half of f of x divided by f of p half plus 0 minus x plus f of x dx. The formula tells us that this is equal to p half minus 0 divided by 2, and that is equal to pi divided by 4. Let's now solve this final integral. The formula, which by now we are used to applying, cannot be applied immediately. Instead, we are going to introduce a substitution that u is equal to x cubed. Well, that means that the differential of u is equal to 3x squared differential of x, and that means that du over 3 is equal to x squared dx. This substitution is going to transform the integral which we are working with into an integral of x squared dx is going to be du over 3, and 1/3 can go in front of the integral as a constant. Sine of x cubed is sine of u, as x cubed is equal to u by substitution, and we have in the denominator sine of x cubed, which is u, plus sine of the argument log of 12, which is a constant, minus u. What happens with the borders of this integral? Let's see what happens with the lower border, the cubic root of log 3. The substitution is u is equal to x cubed, and that is cubed root of log 3, and that is going to be raised to the power 3, which is going to give us log 3 as a result. So the lower border is log 3, and the same thing happens with the upper border, which is log 4. We are now going to take that f of u function is equal to sine of u. The question is, what is f of a plus b minus u? Well, that is equal to sine of a is the lower border, log 3, plus b is the upper border, that is log 4, and minus u. We are going to use the rules of logarithm, and this becomes log 3 plus log 4 to log 3 multiplied by 4 minus u, and that is equal to sine of log 12 minus u. As you can see now, we have transformed this integral to fit the formula. We have a constant of 1/3 in front of the integral, and integral is log 3 to log 4, that is integral of from a to b, sine u du, that is f of u differential of u, divided by sine of u, that is f of u, and plus sine of log 12 minus u is f of a plus b minus u. This is now equal to 1/3 multiplied by b minus a divided by 2, which is 1/3 of the log 4 minus log 3 divided by 2, which is equal to 1/6 of the log of 4 divided by 3. Again, you can see the power of this formula in the way it has helped us solve this incredibly complicated integral. I recommend that you learn by heart this formula, as it will help you solve many difficult integrals instantly, and when you are trying to pass a test, you are basically working against a clock, and every second counts. Thank you for watching. I hope that you have enjoyed this video. Please like, share, subscribe, and leave a comment, and I'll see you in the future video.